Hello friends, today we are going to start the second part of closer look at methods and classes. In the previous session we saw the increment by 10 example. This was this example, increment by 10. So this is the variable A, then this is the parameterized constructor test, A is equal to I. So what I am doing is, when this method is called increment by 10, it will increment the value that is initialized to object will by 10. So every time, first time the value is 2, second time value is 12, and third time after second increase value is 22. Each time in increment by 10 is invoked, a new object is created and a reference to it is returned to the calling routine. Since all objects are dynamically allocated using new, you don't need to worry about object going out of scope. So dynamic creation of object, dynamically allocation of memory to objects is done using new. So where that object is going, is it going out of scope? It is not of your business. So you don't need to worry about it because the method in which it was created terminates. The object will continue to exist as long as reference to it available. There is a reference to it somewhere in your program. Unless and until there is a reference available, that object will not be destroyed. When there are no references to it, the object will be reclaimed at the next time garbage collection takes place. So whenever you are passing object as a parameter to a method, that object's reference is passed as we have seen, and unless and until it is not going out of scope, means it is valid, it is getting operated upon, then at that up to that particular point the object will be in use, and after its use is finished it will be automatically sent to garbage collection by Java virtual machine. The next topic is recursion. Java support recursion. Recursion is a process of defining something in terms of itself. So method is calling itself, it's called as recursion. As it relates to Java programming, recursion is the attribute that allows the method to call itself. The same method will call itself. The method definition will be having method call, the same method call. A method that calls itself is said to be recursive. So factorial of a number is a very much famous example of this. We will see this example. Factorial of a number n is a product of all the whole numbers between 1 to n. For example, 3 factorial is 1, 2, 3 or 6. Here is how we can compute the recursive factorial of a number. We have taken one result variable of integer type if and integer n whose factorial I have to compute. It is passed to fact. Then if n is equal to 1, I will return 1. Why? Because 1's factorial is always 1. Otherwise, what I will do, result is equal to fact of n minus 1 into n. So whatever number that is passed, I will call the same function for the one number minus to that number. For example, if I am passing 5, so how I will compute the factorial of that 5? 5 into 5 minus 1, 4 into 4 minus 1, 3 into 3 minus 1, 2 and into 2 minus 1, 1. And whatever the result, that will be saved in result and I will be returning that result. The same function factorial is calling itself using n minus 1. So this is very famous and very important example to understand how recursion works. Now I am passing here factorial f is equal to new factorial. First of all, I am getting factorial of 3, then factorial of 4, factorial of 5. And output is factorial of 3 is 6, factorial of 4 is 24, Factorial of 5 is 120. All this example we will be taking in practical part. So you don't need to worry about if you are not understanding this. When we will be practicing it, we will be understanding it better. If you are unfamiliar with the recursive methods, fact may be confusing for you. Fact method may be confusing for you. To understand the operation of fact, what you have to do is you have to put any number there, and you have to take a paper and pen and calculate how that method is working. When fact is called with an argument of 1, function will always return 1 because 1 factorial is 1. Otherwise, it returns the product of fact of n minus 1 into n. To evaluate the expression, fact is called with n minus 1. Process repeat until n equals to 1. And when it will become 1, it will return the result. They return the 1, and that 1 will be multiplied with all the numbers. Those are starting with the number specified. We will see one example, factorial of 3. First call to fact will cause a second call to be made with an argument of 2. Fact to be called a third time with an argument of 1. So 3 into 3 minus 1, 2 into 2 minus 1, 1. So 3 into 2 into 1 will tell me the factorial of 3. This call will return 1, which is then multiplied by 2, the value of n in the second invocation, and this result, which is 2, is then returned to the original invocation of fact and multiplied by 3. It will give me answer 6. So to understand it very better, we have to insert println statements into fact function, which will show at what level each call is and what the intermediate answers are. Or you can also take a small paper and pen, and as and when the numbers is decremented, you have to put those numbers onto paper, and then you will understand how factorial is working. When a method calls itself, new local variables and parameters are allocated storage on the stack. So one stack is created, and new local variables and parameters will have entry onto the top of the stack, and the method code is executed with these new variables from the start. So method will call itself first time. 3 will be inserted to stack, top of the stack. Then again fact of n minus 1, 3 minus 1 is 2. So that new variable 2 is put onto the stack after 3. So first entry of stack is 3, second entry of stack is 2. Then again next entry, because n is not equal to 1, so 2 minus 1 is 1. So third entry will be your 1. So 3 on that 2 and on that 1. As each recursive call returns, all local variables and parameters are removed from the stack, and the execution resumes at the point of the call inside the method. So how it will be calculated? First of all, 1 will be popped off the stack, into 2 will be popped off the stack, and then lastly 3 will be popped off the stack. So 1 into 2 into 3 will give me answer 6. So this is the next way to understand how recursion is working. And recursive methods could be said to telescope out and back. Recursive functions may execute more slowly than the normal functions because at every place it have to put the call onto the stack, or it have to call the same function again and again. So additional function calls will take some time, in milliseconds also, but it will take time. For normal or short programs, short methods, it may be we will not feel it very lengthy or very slow, but for the large programs, the recursive functions may feel slow processing. Every time new entry of local variables and parameters are done onto the stack. So pushing onto the stack, popping off the stack will take some time, and That's why it is very much slower than your simpler iterative equivalent. Storage for parameters and local variables on the stack, and each new call creates a new copy of these variables. It is possible that stack could be exhausted. Stack overflow can happen. If this occurs, the Java runtime system will cause an exception of stack overflow. So that when using recursion, you should use it very carefully. You probably will not have to worry about this unless a recursive routine runs wild. Means what? Runs wild means what? Unless and until it is functioning properly. For small programs, for small functions, it is working properly, then you don't have to worry about it. Just when stack overflow happens or occurs, we can handle that situation using try catch. The exception handling part we will be seeing in upcoming chapter. But for now, you have to remember only that first of all, you have to take care while using recursion, and unless and until it is running while, you should not worry about it. You can work upon it for small functions. Main advantage of recursive methods is that it can be used to create clearer and simpler versions of several algorithms. Several data structure algorithms use your recursive functions. For example, quicksort sorting algorithm is quite difficult to implement in an iterative way. Sorry. Also, some types of AI related algorithms are most easily implemented and most easily understandable using recursive solutions. Why it is understanding simpler? Because you have to just remember this function is calling itself. This function is calling itself. So this function is calling itself how many times? Till the end of the number is called. So for quicksort algorithm, many AI related algorithms are most easily implemented using recursive solution. You must have an if to stop somewhere. Like you have to create an if where to force the method, you have to force the method to return without the recursive call being executed. Otherwise, it will be called infinitely and you will go inside infinite loop. If you do not do this, once you call the method, it will never return, and this is a very common error in working with recursion. So one if we have provided in factorial, we have seen. What was that if? If n is equal to 1, I will return 1. So this is the stopping condition of recursion. It is very much important. If you will not specify this stopping condition, your loop will execute infinitely, and this is not expected. So you have to take care all these things. One more example of recursion. The recursive method print array prints the first I elements in the array values. Recursive test parameterized function values is equal to new int of I. So how much large array I am creating, whatever value will be this passed while creating object of recursive test. So if I pass here 5, so new array of 5 variables will be created. If I pass here 10, new array of 10 values will be created. Then display array recursively. So print array function is used recursively. If I is equal to 0, this is the stopping condition to come out of loop. Else print array I minus 1. If I is equal to 0, I just have to return. Otherwise, I have to print array of I minus 1. And how to print it? I minus 1 plus values of I minus 1. So, if I take array, for example here, 10 is passed. So, 10 array having 10 values is created. And object of values I is equal to I. And 10 values, 0 to 9 values are put over there. Then I have to print array 10. So how it will be printed? I pass here 10. So 10 minus 1, 9, 9, sorry. Yes, 10 minus 1, 9, 9 minus 1, 8, 7, 6, 5, 4, 3, 2, and 1. And then 0. 0 is then written. So if it is 0, array of 0 is 0, then array of 1 is 1, and array of 2 is 2, and this way all these values are printed. Now we will see access control. Encapsulation links data with the code that manipulates it. However, encapsulation provides another important attribute, access control. What is encapsulation? Binding together code and data. Data and code that operate upon that data. So both things are grouped together using object. And now one more thing we have to introduce, that is access control. You can control what parts of program can access the members of your class. By controlling access, you can prevent misuse. So whatever data that you are creating or declaring in your class, that should not be accessible outside of class, right? For that purpose, you can specify access control. By controlling access, you can prevent misuse. For example, allowing access to data only through a well-defined set of methods. You can prevent the misuse of that data. So not any third party can come and modify your data. Not any third party can come and directly access your data. That is very confidential. When correctly implemented, a class creates black box which may be used, but the inner workings of which are not open to tampering. What is black box? It is a box, but it is not transparent. It is a black box. You cannot see whatever there is inside in the box. Inner workings of which are not open to tampering. So nobody can tamper the inner data of that class. The classes that were presented earlier do not completely meet this goal. We have not seen access control yet, so we have not understood it, how it is operating. That's why we are introducing it here. Whichever programs we have completed till now, in practical part or theory part, those were not having access controls. But in this class, we will start with access control. Consider the stack class shown in the previous session. We have created for pushing and popping data. While it is true that the methods push and pop do provide a control interface to the stack, this interface is not enforced. What is this? Push and pop methods provide a control interface to the stack. Controlled interface means you can push the data step by step, pop the data one after another. But this interface is not enforced. It is possible for another part of program to bypass these methods and access the stack directly. Because you are not giving any access control, any third party, any other part of the program can come and access the stack and modify the data onto the stack, which may be confidential. In this wrong hands, this could lead to trouble. So, if your stack class is in right hand, it is not the problem. But there is a problem when any wrong hand is having this stack class and operating upon your data which is confidential. So in this section, you will be introduced to the mechanism by which you can precisely control access to the various members of the class. How a member can be accessed is determined by the access specifier that modifies its declaration. And Java supplies a rich set of access specifiers. Some aspects of access control are related mostly to inheritance or packages, and package is essentially grouping of a class. Inheritance and packages are separate detailed chapters upcoming after this session or after this chapter. So now you don't have to worry about it, but some aspects of access control are directly related to mostly both of them. So when we will be viewing those topics, we will be understanding those access control. For single class now, for in this session, since we have not introduced till yet inheritance or packages, for this session we will only be seeing access controls that are applies to single class. So these are important topics. You can note it down. Take a paper and pen. If you are having any notebook, you can write down the notes. Whichever parts in these videos you feel that those are important, those need to be remembered, you can write them down. Because having this PPT video, understanding by viewing and remembering it every time, it is not possible. Every time you cannot access video, means you can access video having internet, but every time you may not have sufficient time to view the video. But when you are having notes with you, what you can do, anything at any time you can read those notes and you can understand it better in your spare time. So learning is a enjoying process. Enjoy that process. So now Java's access specifiers are public, private, and protected. Java also defines a default access level. Protected applies only when inheritance is involved. So what we have to understand, public and private in this case, in this video. Protected is only related to inheritance. And to other access specifiers are described in the next upcoming chapters. Public. When a member of a class is modified by the public specifier, then that member can be accessed by any other code of your project. Not program, any other code by your project. Private. When a member of a class is specified as private, then that member can only be accessed by other members of the class. So in your project, you can have multiple classes. It is not compulsory that in your complete project you are not having more than one class. Till now we have created many more projects. In that all that projects we were having only one class, but you can have more than one classes. If any member in the class you are declaring as private, it is accessed only through other members of the same class. And if you are having more than one classes, your public member can be having, if you are declaring any member as public, any data member like integer, float, or any function as a public, any other code can have access to that data. Now you can understand why main has always been preceded by the public specifier. Why? Main is public static void main. Why it is public? Because it should be accessed by the any code. It is called by the code that is outside of the program, that is by the Java runtime system. So Java runtime system is outsider, and since main is public, it can call that main method and it can start the execution of your program. When no access specifier is used, the by default member of a class is public within its own package but cannot be accessed outside its package. By default member means what? If you are not declaring anything private or public, it will be by default public within its own package. Package, we have already created how to create a package. Right click on the project and create new package. So one package can have multiple classes and one project can have multiple packages. The packages in detail we will be seeing in the next chapters. But for now, you have to understand that if you are not specifying a member as private or public, by default the member of class is public. But when it is not throughout the project public, it is only within its own package public but cannot be accessed outside of its package. In the classes we have developed so far, all members of class have used the default access mode, that is by default public. This is not what will be typically want to be the case. Every time you may now not be dependent on only default access modifier, that is public. You can you may be wanting it to be private or public or protected. You will want to restrict access to data members of a class, allowing access only through methods. Which data members? Those are confidential as per your convenience. As there will be times when you will want to define methods that are private to a class. Where there will be a times when you will be wanting the private methods, private members to be declared. Access specifies precedes the rest of the members type specification. For example, it must begin a member's declaration statement. How we declare a data member? Integer I, float j, and then boolean character, boolean choice, and like this. And how to declare them public or private? You should begin a member's declaration with that public or private access specified. So this is the example: public integer I, semicolon, private double j, semicolon, private int my method int a comma character b. So methods can also be declared with access specified. Those can also be private, public, or protected. To understand the effects of public and private access, consider the following program. This program demonstrates the difference between public and private. This is the int a default, by default public, default access public, int b public access, and private integer c private access. So int a and int b have default access, but that is public, and int c is private. Now void set c. Why I use set c only? Because outsider or a caller of a method, caller of this class method, cannot directly access this integer c because it is private. So how to set them? Methods access to c, void set c int of I. Set c value, c is equal to I. Int get c and return the value of c, return c. Class access test. Public static void main. In this I am creating one test object, test ob is equal to new test. These are okay, and a and b may be accessed directly. Why? Because those are public, by default public. We can access it like object name dot member name, object of class test. ob.a is equal to 10, ob.b is equal to 20. This is not okay and will cause an error. We cannot access it like this, ob.c. Why? Because test C member is declared as private. This is private. So you cannot access it like object name dot member name. So it will cause me error. So how to do it now? Object dot set C 100. Then ABC object dot A, object dot B, and how to get it? Object dot get C. You can see the difference of public and private. For public members, I can directly assign them using object dot A is equal to 10, object dot B is equal to 20. But here for setting C, I cannot write it like object dot C is equal to 100. I have to set it using a method which is public. ob dot set C 100. And to get the value, I can get it ob dot A, it will be printed, ob dot B, it will be printed, but ob dot C will not be printed. For that, I have to write this function integer get C. This will return me the value of C. Inside the test class, A uses default access, which for this example is the same as the specifying public. B is explicitly specified as public. Member C is given a private access. This means that it cannot be accessed by code outside of its class. Now, inside the access class, C cannot be used directly. So, you cannot access the value of C directly. It must be accessed through its public methods, setC and getC. Those are called in Java getters and setters methods. For each and every variable, those are created as private. You don't have to write them manually. Those functions can be created automatically using select the variable and then right click and generate getters and setters. While doing programs practicals, we will be viewing how to do it. If you were to remove the comment symbol from the beginning of the following line, it will give me error. Then you would not be able to compile this program because of the access violation. Now, we have more practical example of stack. Both stack and top of the stack are private. What is stack in this case? This is the array stack, integer array, and top of stack is an integer number. In the previous cases, we declared them as default access specifier, that is public, and here we are declaring them as a private. Why? Because for us it is now very much confidential. We are now improving the version of stack. This means that they cannot be accidentally or maliciously altered in a way that would be harmful to the stack. If that stack would go into wrong hands, as we have seen in the previous slides, it may be creating a problem. So we do not need that problem. For that purpose, I declare it as a private and private. Now initialize the top of stack as usual. Push the item onto the stack. Void push integer item. If top of stack is full, otherwise first increment the top of stack and then put the item onto the stack. Why I cannot write directly on the top of stack? Because there is already one item present on the top of the stack. And if I will write it onto that, it will override the previous item. So for that purpose, we will firstly increment the top of stack using increment operator, and then value is updated and then item is put onto the stack. Pop an item from the stack. If top of stack is less than 0, stack is underflow and return 0. Otherwise, return stack top of stack minus minus. So fix that top of stack minus minus. First of all, element at the top of stack is popped and then its value is decremented by 1. Sorry. As you can see, both stack, which holds the stack, and top of stack, which is the index of the stack, are specified as a private member. This means that they cannot be accessed or altered except through push and pop. So push and pop are only functions who can directly access these two data members. Making top of stack private, for example, prevents other parts of your program from inadvertently setting it to a value that is beyond the end of the stack array. For example, means what? It will prevent when you are making that top of stack private, other parts of your program cannot alter that value of top of stack to a value that is beyond the limit of the stack array. So it cannot make the stack underflow or it cannot make the stack overflow. So both cases are allowed only through push and pop function. The following program demonstrates the improved stack class. Now, one more example. My stack is equal to my stack 1 is equal to new stack, my stack 2 is equal to new stack. Pushing the data onto the stack. Here also pushing the data onto the stack. Here 0 to 9 are pushed. Here 10 to 19 are pushed. Pop those elements out of the stack. So while popping only for iteration purpose, as we have seen previously, I have explained it. You have to just iterate it 10 times. For that, here for loop is different than this for loop. So I will be popping here 10 times. I will be popping here also 10 times. Stack in my stack 2. Now, my stack 1, that is object of stack 1 dot top of stack, is equal to -2. I cannot write it like this. Why? Because top of stack is private. Also, I cannot write it like this. My stack 2 dot stack of 3 is equal to 100. I cannot alter the value of the fourth element as 100. So this is the malicious operation done by malicious person or wrong person. It is trying to modify the stack. Here there are only numbers, but you may have the confidential data that should not be modified. For that case, we have initialized it to private and this also to private. Although methods will usually provide access to a data defined class, this does not always have to be the case. Methods will usually provide access to a data, but not every time this is possible. It is perfectly proper to allow an instance variable to be public when there is a good reason to do so. So, declaring public variables is okay. Not every time you need a private variable, you can declare them public also when there is a good reason to do so. Most of the simple classes we have seen so far were created with little concern about controlling access to instance variables for the sake of simplicity. So whatever programs we have seen so far, we have declared them as public or by default public. So there was no need that any confidential data was getting modified. But now for the vast programs or for the program that is having confidential data, you may require the private access modifier. However, in most real-world classes, you will need to allow operations on data only through methods. Only through methods means what? Getters and setters, or any other method that can access the private data members. Now, we will understand static. There will be times when you will want to define class members that will be used independently of any object of the class. So every time you create a class object and then you will access the member house, member name, object name dot member name, object name dot method name. But you may have situations sometimes that you may require to call that method without use of object. In that case, we will use static. Normally, a class member must be accessed only in conjunction with an object of its class. However, it is possible to create a member that can be used by itself without reference to a specific instance or specific object. So without creating object or without giving a reference of any object, you can directly call it if that member is declared as static. To create such a member, precede its declaration with the keyword static. When the member is declared static, it can be accessed before any objects of its class are created and without reference to any object. Static member can be accessed before any object of that class is created and without use of any object of that class. You can declare both the methods and variables to be static. So methods can also be static, variables can also be static. The most common example of static member is main. Main is declared as static because it must be called before any object exists. Why we declare as public static void main? First of all, it is public because as we have seen, Java runtime system has to call it from outside, so it is public. Why it is static? Because it must be called before any object exists, without use of any object. You should be entering into the program somewhere without creating any object. For that purpose, main is declared as static. Instance variables declared as static are essentially global variables. When objects of its class are declared, no copy of static variable is made. So these are the important points you should remember or you should note down. First point is instance variable declared as static are essentially global variables. Those are global. When objects of its class are declared, no copy of static variable is made. Instead, all instances of the class share the same static variable. So, no copy of static variable is created. All instances or all objects share the same static variable. Methods declared as static have several restrictions. First restriction is they can only call other static methods. They must only access static data, and they cannot refer to this or super in any way. And super relates to inheritance directly, and it is described in the next chapter, upcoming chapter. So three restrictions are, you have to remember. First is they can only call other static methods. They must only access static data. They cannot refer to this or super in any way. If you need to do computation in order to initialize the static variable, you can declare a static block. A block means what? Opening and closing curly braces. Whatever you will be writing in that opening and closing curly braces will be called as a block. And you can label that block as static, as we have labeling the break label. When we were using break label, continue label, like this. We will be seeing these examples while practicing in the practical part. You can declare static block that gets executed exactly once when the class is first loaded. What does this line mean? If you now want to do a computation in order to initialize your static variables, you can declare a static block that gets executed exactly one time when the class is first loaded. The following example shows a class that has static method, some static variables, and a static initialization block. To use static is a class, we have created static int a is equal to 3, static int b. Then there is a static method. These two members are declared as static. This is a static method. Why they are called as static? Because static method can only access static data. They can only call other static methods, and they must only access static data. So the data that is operating upon this method have data that it is operating upon, it should be static. For that purpose, this is static and this is also static. Now, this is the static block. There is opening and closing curly braces, and whatever you will write in this opening and closing curly braces preceding static keyword will be called as static block complete. So this is static block, and here I am printing static block initialize. B is equal to A into 4. So what is B? A is equal to 3, static int B, and X is passed as a parameter to method. So I have passing 42. So 42, X will be initialized to 42, A will be initialized to 3, and B is equal to A into 4. So it will be 3 into 4, that is 12. As soon as your static class is loaded, all of the static statements are run automatically without use of object. First of all, A is set to 3. A is set to 3 here. Second, static block execute, which prints a message and then initialize B to A into 4 or 12. Secondly, static block is run, B is calculated, and thirdly, method call is run. When main is called, the main which calls method passing 42 to X. So X will be initialized to 42. The three println statements refer to the two static variables A, B, as well as the local variable X. So output of this static block is, output of this program is X is equal to 42, A is equal to 3, B is equal to 12. Outside of the class in which they are defined, static methods and variables can be used independently of any object. In the class, outside of the class in which they are defined, static methods and variables can be used independently, means without use of any object. To do so, you need to only specify name of their class followed by the dot operator. This is the example. Call a static method from outside of its class. How to access it? Class name dot method name. Yeah, class name is the name of class in which static method is declared. As you can see, this format is similar to non-static methods we have already seen through object reference variables. Static variable can be accessed in the same way by use of dot operator and on the name of the class. So you can access class name dot class name dot variable name as well as class name dot method name. This is how Java implements controlled version of global methods and global variables. So whatever global methods and global variables are declared inbuilt in Java, in the Java class library, they declare them as a static and it controls the operation of control version of those global methods and variables. Here is an example. Inside main, static method call me and static variable b are accessed through the class static demo. So this is the class demo, static demo. In static integer a is 42, static integer b is 99, and static method is calling a is equal to and printing the value of a. Now static by name, static demo dot call me. So this is the second class. From the second class, you are accessing these variables and methods. So how to access them? Class name dot method name. Static demo is the class name and method name is call me. So it will print a is equal to 42 and b is equal to static demo dot b. What is static demo dot b? Directly you can access using class name dot variable name. Static demo dot b is equal to 99. So here is the output of this program, 42 and 99. Now next topic is introducing final. A variable can be declared as final. Doing so prevents its content from being modified. So whenever you are declaring them final, you have to initialize. You must initialize the final variable when it is declared. And you cannot modify the final variable throughout the program. For example, final int file new is equal to 1. Final int file open is equal to 2. Final int file save is equal to 3. Final int file save as is equal to 4. Final int file quit is equal to 5. Subsequent parts of your program can use file open as if they were constants without fear that value has been changed. They were constants. Why? Because they have already defined. Their value is already defined and you cannot change those values. It is a common coding convention to choose all uppercase identifiers for final variables. So generally we write uppercase identifier for final variables. Variables declared as final do not occupy memory on a per instance basis. Variables those are declared as final, they do not occupy memory on a per object basis. Thus a final variable is essentially constant. The keyword final can also be applied to method, but its meaning is substantially different than when it is applied to variables. The second use of final we will be seeing when we will be understanding inheritance. The last topic is arrays revisited. Arrays, or we have already seen arrays, single dimensional array, two-dimensional array and three-dimensional array. Now that you know about classes, important point can be made about arrays. They are implemented as objects. Arrays like strings are implemented as objects in Java. Because of this, there is a special array attribute that you will want to take advantage of, and that is called as size of an array. The number of elements that array can hold is found in its length instance variable. So how to find out size of an array? Its length instance variable. All arrays have its variable and it will always hold the size of the array. So here is one example. First array is one-dimensional array, single array. of 10 variables. Second is already initialized with 3, 5, 7, 1, 8, 99, 44 minus 10. Here total number of elements it can hold are 10. Here in the second array total number of elements it can hold are 8, and here total number of elements are holding it is 4. Length of array is 10. Length of array 2 is its length, and its third one length. It is 10, 8 and 4. Size of each array is displayed in the output. Value of length is nothing to do with the number of elements that are actually in use. So while initialization, how many elements are stored in array, which will be your total length of an array. It does not relate to how many elements are actually getting used. It only reflects the number of elements that the array is designed to hold. You can put the length number put to use in many situations. So we will see improved version of stack class, 10 element stack. This version lets you create stack of any size. The value of stack length is used to prevent stack from overflowing. Private integer stack array, integer top of stack. Stack is initialized to new int size. Top of stack is -1. Push the item onto the stack. Like previously, if stack is not full, push the item, pop the item off the stack, stack underflow. Otherwise, return pop top of the stack, pop top of the stack, and then two stacks are created of 5 and 8. Then I'm putting the data onto the stack and popping the data of the stack. There we have created two stacks, one 5 element chip and other 8 element chip. So a size of the array is 5 and 8. The fact that arrays maintain their own length information makes it easy to create stack of any size. So array can maintain its own information with it using length instance variable. So you can create stack of any size. So this way we have completed part 2 of closer look at methods and classes theory part 2. In the last part of theory we will be covering the remaining topics, and after that we will be viewing the practical part, how actually the methods and classes in detail work. So meet you in the next session. Thank you so much.